What if your AI agent could survive crashes, pause for human input, wait hours, or even days, and then pick up exactly where it left off? That's the problem most agent systems struggle with today. They look powerful in demos, but once you add real-world complexity, long-running workflows, external tools, failures, approvals, and unpredictable waiting, things get fragile fast. In this video, we're breaking down the Agent Executor, the layer that makes agents reliable enough for real production use. We'll look at why agent workflows are nonlinear, why durable execution matters, how agents can resume after interruptions, and how flexible deployment lets you run them on your own infrastructure. By the end, you'll understand what it takes to move from a simple AI demo to agents that can actually operate in the real world.
Hey everyone, let's just be real for a second. If you're a software engineer building AI systems right now, you already know that the whole honeymoon phase of simple, single-prompt chat apps, yeah, it's officially over. Today, we're pushing AI to do real, complex work. But the second we start scaling these complex agents, we run headfirst into an absolute operational nightmare. So in today's explainer, we're going to unpack a major new release from Google that's designed to solve this exact chaos. It's called Agent Executor.
So ask yourself this: what actually happens when your agent fails on day 2? Really think about it, because we've literally all been there. You build this incredibly smart agent, right? It runs flawlessly on your local machine. But then you push it to production, and suddenly it's grinding on a task that takes hours, maybe even days. And right in the middle of this massive multi-step workflow, boom, a network timeout hits, or a sub-agent crashes. Your long-running workflow is completely dead in the water, and all that expensive compute, all that context, just gone. It's a massive headache for any engineering team trying to build reliable systems.
Look, you are definitely not alone in feeling this pain. Check out this quote straight from Google's engineering team. They state it perfectly. Long-running agent workflows are fragile and incredibly hard to manage reliably and efficiently in production. As tasks stretch from seconds out to hours or days, our standard infrastructure abstractions just completely break down. The tools we rely on to manage standard microservices just weren't built for the unpredictable asynchronous nature of autonomous agents.
All right, Section 1, Introducing Agent Executor, Google's distributed agent runtime.
Google just dropped what might honestly be the magic weapon we've all been waiting for. Agent Executor is their new open-source runtime standard for agent execution, resumption, and distributed deployment. And guys, this isn't just some shiny new wrapper, it's a fundamental runtime layer built entirely from the hard lessons Google learned solving these exact deployment issues internally. It comes packed with 5 native capabilities designed specifically to tame production chaos: durable execution, secure isolation, session consistency, connection recovery, and trajectory branching. Secure isolation gives you those secure-by-design sandboxes so a rogue code generation doesn't take down your broader service. But as engineers, the pieces that should really grab your attention are how this core runtime handles state and concurrency.
Moving into Section 2, a deep dive into durable execution and consistency.
Let's actually slow down for a sec and look at the exact mechanics of how this runtime prevents data loss when things inevitably go sideways. First up is durable execution. By definition, this is the ability to automatically resume agent workflows after network outages or human-in-the-loop pauses. Think of it as an automatic safety net for your infrastructure. Whether you're running a single agent, a massive harness, or a specific tool, this back-end resilience means an interruption doesn't force you to start from scratch. Say your workflow needs a human to approve a financial transaction or merge some code. The system just gracefully pauses, safely waiting, without burning through your resources or losing its place.
But how does it actually pull that off under the hood? Well, it's powered by automatic event logging and snapshotting. As your agent navigates its complex logic tree, Agent Executor is quietly taking snapshots and keeping a super rigorous event log. If the power cuts out or a container crashes, the runtime uses those logs and snapshots to perfectly restore the agent's exact state right before the failure. It's basically like having autosave permanently turned on for your entire distributed infrastructure.
Okay, but restoring state is only half the battle, right? What about when everything is firing at once? That brings us to session consistency. In these distributed agent workflows, you constantly have multiple sub-agents and tools trying to update a shared session state at the exact same time. It's pure concurrency chaos. Without strict management, this leads straight to race conditions and corrupted data. Session consistency is the crucial fix to keep that shared state perfectly accurate and uncorrupted.
And Google's fix for this is incredibly elegant.
Agent Executor uses a built-in single-writer architecture. Take a second to appreciate that phrase. By enforcing a single-writer architecture, the runtime acts as an unyielding traffic cop for your data integrity. It strictly sequences these simultaneous update attempts, guaranteeing that your shared session state is never incorrectly overwritten or ruined by a race condition.
Building on that rock-solid state management, we get two really fun developer features. First, connection recovery, meaning if a client drops off due to a spotty network, they just reconnect and the system backfills whatever responses they missed. But trajectory branching, that's where it gets really powerful. Because the system is constantly checkpointing, you can branch an agent's decision path at literally any point. You can safely test entirely different logic paths without losing the overarching context or state of your main agent.
Section 3. Flexible deployment, or really, owning your compute.
So the runtime is incredibly resilient, but where does the code actually run? Vendor lock-in is a massive headache for enterprise teams. You want the absolute best runtime, but you definitely don't want to be forced into a single provider's ecosystem. Well, Agent Executor is built around the idea of owning your compute. You can seamlessly mix and match deployment models. You can run Google's state-of-the-art Antigravity 2.0 harness right alongside their frontier agents like Deep Research, or use the custom-managed agents API, but it's totally harness agnostic. You want to deploy custom agents built with LangChain, LangGraph, the Agent Development Kit? Go for it. It bridges everything.
The level of empowerment here for software engineers is just huge. You fully control execution on your own data plane. If you're dealing with strict compliance requirements or highly proprietary workflows, you can keep your agents, custom tools, and model context protocols completely locked down within your own self-managed compute. You draw the custom isolation boundaries, you enforce the workload policies, you get all of Google's robust orchestration, but your workload never has to leave your sovereign control.
All right, Section 4, the scaling wall, and introducing Agent Substrate.
So we've nailed resilience and flexible deployment. But what happens when your project blows up? Like, when you go from a dozen agents to hundreds of millions, you hit a massive wall. And to understand why you hit that wall, listen to this brilliant analogy from the Google Kubernetes Engine team. They point out that, unlike traditional software, agents are nonlinear programs that wait for external inputs. This is the real light bulb moment. A traditional web service gets a request, processes it, and returns a response. A straight line. Agents, they don't do that. They think, call a tool, and wait. They ask a human for permission and wait. All that asynchronous waiting completely shatters traditional compute abstractions.
The contrast here is just stark. Standard Kubernetes is an absolute marvel of engineering, but it's optimized for thousands of long-running services. Agent workflows create massive amounts of chatter. We're talking millions of sub-second tool calls, pauses, and context switches. Shove all that through a standard Kubernetes control plane, and you will totally overwhelm it. And that is exactly why Google partnered with the GKE team to build Agent Substrate.
Agent Substrate is essentially a new level of abstraction for Kubernetes. It specifically moves agents onto and off of ready compute capacity in real time. It takes the core secure runtime and snapshotting features we talked about and pairs them with a minimal control plane. By bypassing some of those standard Kubernetes limitations, it achieves way lower latency and unbelievable compute efficiency for these nonlinear programs.
And when we talk about scale here, we are not talking about a tiny bump. Together with Agent Executor, Agent Substrate's new control plane is literally engineered to handle hundreds of millions of registered agents efficiently. Just let that number sink in for a second. That is the true foundation you need for the largest enterprise agent deployments on the planet. But here is the absolute best news for the DevOps folks tuning in. You don't have to rip and replace your infrastructure to get this scale. Agent Substrate lets you stay entirely within the Kubernetes ecosystem. Because it's built on top of K8s, you still get to use standard scheduling, horizontal scaling, and the exact same declarative configuration you already know and love. You get highly specialized agent infrastructure without reinventing the wheel.
So here's the bottom line. The era of fragile, unscalable AI prototypes, it's over. The open source tools to build resilient, distributed, enterprise-grade agents are sitting right in front of us. Agent Executor is currently in preview, and Google is actively telling developers to jump in and test it out. So my question to you is, are your agents ready for the substrate? Head over to their open source GitHub repo, validate your own workloads, and start building with actual reliability. Thanks so much for joining me on this explainer, and I'll catch you on the next deep dive.